Hello everyone, welcome to this series of mathematics lessons. In this presentation, we shall study about Heron's formula. Heron's formula. Walk around your classroom along the sides of the floor. Imagine that the length of your classroom is 10 meter and the width of the classroom is 8 meter. So you walk 8 meter along this side and 10 meter along this side. The perimeter of this classroom is 2 times 10 plus 8. 10 meter length and 8 meter width. 2 times 10 plus 8. This is one way of calculating the perimeter of the rectangle. What this means is, instead of writing perimeter of all the side, we are taking the length and the width. We can also write perimeter as 10 plus 8, which is this 10 plus 8, one part is 10, the remaining two sides are, this is 8 meter and this is 10 meter. So 8 and 10 are repeated 2 times. So instead of writing this, we write it as 2 times length plus width. Length plus width. So 10 plus 8 is 18. 18 times 2 is equals to 36. So the perimeter is 10 plus 8, which is equals to 16. 16 times 2 is equals to 36. So the perimeter is 36 meter. Notice the unit is meter, and the area would be 10 times 8. 10 times 8, which is equals to 80 meter square. Notice the unit of area is meter square. This is about rectangle. Imagine you are sitting on a triangular garden. How do you find the area of this triangular garden? Area of triangle is given by half times base into height. Why 1 by 2 half? Area of triangle could be derived from area of rectangle. We know that the area of rectangle is length base times height. If you cut this rectangle into two equal halves along this diagonal, we will get two triangles. This is one triangle and this is one more triangle. So basically area of triangle is equals to half the base times height. This is area of rectangle. When you divide it by 2, we will get the area of triangle. Notice this area of triangle is applicable only for the right angled triangle, for height and for a given base. How do you find the area of triangle which is not right angled? Now let us see how to find the area of equilateral triangle. Equilateral triangle having equal side length. Now let's try to find out the area of this equilateral triangle. Of side 10 centimeter. This side 10 centimeter, this side 10 centimeter, this side 10 centimeter, and this side 10 centimeter. We need to find the area of this triangle PQR. PQR of side length 10 centimeter. If you observe this triangle, now let's split this triangle into two equal parts by drawing the perpendicular at the middle of this side QR. You can also take the middle of PQ You can also take the middle of PQ, this point, or you can also take the middle of PR approximately at this point. Here we are considering the middle point of side QR. We name it as M, then we will join PM. Now we have two equal parts, this triangle and this right angled triangle. Both are right angled triangle. In order to find the area of triangle, we need base and height, right? For this problem statement, we are not given with the height, the perpendicular height. The only data which is available is the side length. So we need to find the length of height. That is the reason we drew a perpendicular at the midpoint of a given side. We need to find the length of this perpendicular height. So let us apply Pythagoras theorem for this half part of the triangle. We applied the Pythagoras theorem here. PQ square is equals to, that is the length of the square of length of hypotenuse, is equals to PM square plus QM square. We know the length of PQ, which is 10 centimeter, and we also know the length of QM, which is half of length QR, that is 5 centimeter. This length is 5 centimeter. PQ square 10 square is equals to QM square, which is equals to 5 square, and PM square. This is what we need to find. So PM square is equals to 10 square minus 5 square. 10 square minus 5 square is equals to 100 minus 25 equals to 75. PM square is equals to 75. Apply square root on both sides of the equation. We will get the side length PM, which is equals to square root of 75. This could be further simplified. We can write square root of 75 as square root of 25 times 3. 25 times 3 is equals to 75. And we can split this square root. Square root of 25 times square root of 3. Hope you know this property. Square root of 25 is 5. 5 times square root of 3. The length of PM is 5 times square root of 3 centimeter. The unit is important here. Now we have two methods. Either calculate the area individually, then multiply it by 2, because this part and this part are same. Calculating only this part of area and multiplying it by 2 is one way of doing, or calculate by taking the total base length and apply this equation, apply this formula, half times base into height. Here the second method is used to solve this problem. Half into base into height. Half into base is 10 centimeter and height is 5 times square root 3. Square root of 3. 2 1 times 2 5 times 5 into 5 is 25. 25 into square root of 3 centimeter square is the area of this triangle PQR. This is about equilateral triangle. Similarly, we can also find the area of isosceles triangle. In isosceles triangle, two sides of a triangle will be of equal length. Now we need to calculate the area of this triangle XYZ, where the side length of XY is equal to 5 centimeter and side length of XZ is equals to 5 centimeter and the length YZ is equals to 4 centimeter. Here also we can follow the similar approach. Draw a midpoint on this other side and mark it as point P. Then draw a perpendicular along XP. The given data is the length of XY, the length of XZ and the length of YZ. The length of YZ is 8 cm. If we divide this length by half, we will get midpoint at 4 cm. So the length of YP is equals to 4 cm. Length of XY is equals to 5 cm. We need to calculate the length of XP. Once we get this length, perpendicular height length, we can calculate this area of triangle. Using Pythagoras theorem, we will apply Pythagoras theorem for this triangle. Even we can also apply Pythagoras theorem for this triangle also, since both will be same. In this example, we will consider this part. We can apply the Pythagoras theorem for this right angled triangle, which is equals to xy square is equals to yp square xp square. We need to calculate the length of this xp, so we will keep that in one side of the equation. So xy square minus yp square is equals to xp square. Xp square is equals to xy square plus yp square. The length of yp is 4 cm, so 4 square. Length of xy is equals to 5 cm, so 5 square. 5 square minus 4 square is equals to 9. Xp square is equals to 9. We only need the length of xp, not its square. So apply square root on both sides of the equation. Xp is equals to square root of 9. Length of xp is equals to 3. Length of xp is equals to 3 cm. Now we can apply the formula half into base into height. Half into base is 8 cm and height which we got is 3 cm. Half into base into height, half into 8 into 3. 2 1 times, 2 4 times, 4 times 3 is 12. 12 cm square is the area of this isosceles triangle. The content of this recording is borrowed from Karnataka Textbook Society, Bangalore under Fair Usage Policy. This video is presented by Avari Technologies. Please do hit subscribe button to get more content. Thank you.